Alright, now we're going to look at finding the domain and range for a quadratic function. You guys have been learning a lot in this class about quadratic functions, so here's an example of one. We've got y equals x squared plus 1. If I graph this one, I'd have a vertex at 0, 1, and I'm just going to go ahead and put on some points here. Again, not focusing today on how to create this graph, but if you have questions about this, this would be a good thing to go over in a Q&A session about how to graph a quadratic function. Okay, so I've got my arrows on because I am going on forever and ever and ever. And for my domain, I'm thinking, okay, horizontally here, is there any x's that I'm not seeing showing up on my graph? So obviously I have x values here where I have points, but even if I keep going more and more to the left, I would have a corresponding point on the graph for each of these x values. Same thing on the right since my graph is symmetrical. So for this one, I've not got anything very exciting again. I've still got all real numbers. In the equation, I can plug anything I want in for x. There are no restrictions on what I'm allowed to plug in for x as far as real numbers go. So my domain, again, would still be from negative infinity to positive infinity with parentheses around the infinities. Or I could write out all real numbers or use this special all real numbers symbol. Okay, now for the range, I do have a restriction because if you'll notice, I don't have anything at all for this part of the coordinate plane. So vertically, I don't have anything below, it looks like 1. Okay, so my range is all y values that are greater than or equal to the number 1. I should put that they could be equal to 1 because I have an actual point there at 1. Okay, so when I write this in interval notation, I could say I'm going from the number 1 up to infinity, and I use a bracket around the 1 because I'm including that number in my range. There is a point that goes with that number. And then again, my graph has points that are all corresponding to y values that are above 1. So that's why I have y is greater than or equal to 1. So there's your first restriction that you've seen so far. And this is pretty typical of quadratic functions. We usually can plug in anything we want for x, and we have domain of all real numbers. But then we have some restriction based on where the parabola starts, what direction it's going. It could be going down. In that case, we would flip around the inequality symbol. So this will be your example for quadratic functions. Next, we'll look at an exponential function.